Good, good, good. I just had a scare really fast there. My internet decided to crap out on me.
I feel like I would be worried about that every single month.
Yeah. Well, that's the first that's happened this close to go live, but well. Hey, okay, so let's test something really fast just to make sure this works. In order for you to present, I'm gonna screen share with you, and I'll have to give you host control. And then when you're done, you'll shoot it back to me. Cool?
Okay.
So have you navigated Zoom before? You know the controls in Zoom?
I know how to screen share. I don't know if I've given host back, but you can certainly find that out.
Cool. So it's under participants. If you open up your participants panel,
Yep.
and then you'll see me, Justin Stevens, and then it'll say host next to me right now. Maybe it won't, I don't know. But once you have ability to host, there will be like a more drop down, and then you can give back host. So right now, I'm going to make you the host. Okay? The music will stop, and you'll just have control.
Okay.
There it goes.
I'm gonna test that sharing my screen.
And I may have to stop. Oh, yeah.
Awesome. And I can share everything. I wonder if I can get this to go away. Cool. That works for me.
Oh, no. Oh, no. Did it happen? I know. Am I back in? Or no?
Hi.
Okay. Youch. My internet just completely shut down again. No, that was fun.
So that like dropped, it froze up when I gave it back to you. But I was also screen sharing at the same time. So I'm gonna not do that next time.
Well, I think what happened was my internet again cut out.
Oh, okay.
Yeah.
Because everybody else was cut out too. Like everybody else was frozen. So I don't, we'll figure it out, I guess.
Yeah. Cool, cool. Well,
It'll be fun. It'll be fun to see what got recorded, I think.
yeah, yeah. This is kind of nuts. Okay. Okay. Try this again. Okay. There we go. Just need to do a few more things and I'm good on my end.
you have like a MPEG at the end of this or a link where I could download the recording?
Yes.
Awesome.
Working on that right now. Working on that. Okay, so this is crazy. Yeah, so I'm also streaming this on Twitch as well. So it'll be hosted on Twitch. Kind of crazy. Just gotta be able to see. I'm not gonna be able to monitor the chat on Twitch though right now. No, maybe I can. Maybe I can break this out. I doubt anyone's gonna pop in there, but who knows? Okay, cool. All right, so that's all fun. That's all set up. Okay, I've got a crap ton of panels, and now I need a third screen. So let me also. Over to screen share. I wish I could screen share and share music at the same time, but I don't think I can. That's kind of a bummer. It's a bummer for you guys because it's really dead silent and kind of annoying, obnoxious. Okay, so give me a second or two. I gotta close the door really fast and I'll be right back. Okay, so Logan. Okay, how this is gonna go? Probably. I'm just kind of. You were here last time. You know the drill a little bit. I'm just gonna kind of fill the space with some silly musings that I come up with for a little while till maybe around 6:35, 6:40, somewhere in there. I'll do an intro about what WebGeeks is and DSMJS are, and then I'll hand it over to you, and I'll make you host. You'll run through your presentation. Let me know if you need anything. At the end, if you want to do questions, we can. And then I'll also try and do that breakout social thingy again. Feel free to stick around if you want. Hop off if you'd like. It's up to you. But yeah, I think that's how it'll go. Any questions, or does that sound good?
Sounds good to me.
Okay. Okay.
Yeah, I'll probably do some questions at the end. So when there aren't any others questions, I'll just hand it back to you.
Okay, cool. Yeah, that sounds good. And is my screen sharing? Can you guys see what I'm seeing here?
I can see a pretty sweet code pen.
Yeah, there's nothing that really gives me a good indication that screen is being shared, but okay, I'll just, so anyway, the reason that I have this up actually is because I don't know if anybody's aware, but this month in December 2020, Adobe Flash has officially sunset. That thing is dead, gone, and will cease to exist. It's no more. And so I've just been kind of looking at how we have chosen to replace Flash. I don't know if all of you remember, but I grew up in coding sites in an era where Flash was very prevalent. And so, an entire website from the very first splash page to the contact page was all Flash, every bit of it. And every bit of it was animated and obnoxious, but cool and all of that. And I mean, some of my most favorite websites in the world were Flash sites, and they no longer exist anymore. So anyway, I've just kind of thought it might be interesting to look at some techniques on how we chose to replace this this part of our history, which I think is kind of important. I mean, a lot of people hated Flash for good reason. Flash should be gone. It's good that it's gone, but I think what it gave us was pretty invaluable.
You could build some pretty cool interfaces. I mean, I think my first like web class wasn't anything about HTML or CSS. It was just Dreamweaver and Flash and mixing that in between, which was pretty fun.
Yeah, and I mean, I've built sites that are completely keyframes, just like keyframe by keyframe, horrible way to do things. But I remember like toward the tail end of Flash, there was this strange framework that actually allowed you to kind of wire things up and build out a site in Flash. I do not remember the name of it, but it was pretty interesting. Anyway, another thing that kind of goes along with this that just kind of happened today, transform properties got a little bit easier to write. I don't know if anybody writes this all the time, but this is very topical because, you know, if you're going to do animation in CSS, you're most likely going to hit transform, and so that's kind of a nice little thing that just happened. I don't know if anybody who the lines are so blurred today, it's just interesting to call yourselves a front-end designer, but or front-end developer. But does anybody work on a lot of animation? And if so, what primarily is the driving language behind that animation? And feel free to just jump in and say anything.
Mine's just been CSS animations when I need to, I guess. I wouldn't say I'm a user of code, not someone that can create them. Take other people's works, I guess. They're sharing them for free.
Yeah. Yeah. And I think that is like the beauty of Flash. That's what Flash gave us. Flash was this tool that made all of this obtainable, right? And we no longer have that aspect of it. Anyone could step into Flash, you know, whether they were not a coder or not, and they could animate something cool and interesting. It's much more challenging nowadays, to some degree, depending on what you want to do, I guess. Here's another really interesting code pen. If you're interested in reading through all this, it's a pretty cool breakdown on just maps and event listeners, and just to see how this was accomplished is kind of fun to read through. And another thing that I've been seeing a lot on CodePen, honestly, I'm not a huge fan of, but Pug. For this, it makes a lot of sense. This is just an SVG. And so it's fine. Like, I can't stand reading SVGs anyway, so this is fine. But
what is Pug? I've never heard of that.
It's just an HTML like shorthand like language that compiles into raw HTML. Haml is very close to Pug, and I'm guessing, I don't know, they support quite a few. Yeah. Pug is the new cool thing, though. Cool kids are doing it, so I guess we should be too. And then I thought maybe it'd be kind of interesting to look at some really interesting experimental things with what's being done on the web today, sans Flash. And so this is a pretty cool site. I remember this from a long time ago. This site's been around for a while. And it just has a lot of quirky and cool things that you can do, you know, with experimenting just all over. with I believe Canvas and WebGL and SVG and a whole bunch of things. The sheep one was kind of funny.
So I have seen a bunch of like Flash emulators pop up that have been compiled in WebAssembly. Have you checked any of those out?
So I haven't checked any of them out. I know when I was doing some research for your talk, kind of familiarizing myself with Rust. There is a compiler made in Rust, something like that, that does convert FLVs to be able to run natively in the web. As far as I know, maybe I'm like surmising that a little bit incorrectly, but that's the gist of it. And I think it's an open source project that's backed by Newgrounds. So kind of cool. Nice to be able to save Newgrounds. Newgrounds did not make the switch, you know, like Unity 3D was originally in Flash. Then they made this switch to JavaScript, and now it's like very relevant. Newgrounds went all in on Flash and is just kind of like Flash forever. Now, how could you possibly migrate over that giant library of content? But yeah, maybe there's hope for it yet. Anyway, there's some really fun ones in here. I don't know how achievable or obtainable any of this stuff is. I mean, I'm guessing this is some kind of like play with SVG, maybe. The most that I've ever done with SVG in animation tends to be like small icons or maybe an animated map, but it's really hard, like incredibly hard to do animations in HTML and JavaScript.
I was just assumed somebody had some tool that did it for them.
So there is a tool like Adobe Animate CSS, CC, Creative Cloud. I can't speak to that tool. I don't know how good it is. I assume if you use that, you also use XD. So, you know, maybe it's good, maybe it's awesome. I'm not really sure. But I doubt that it's going to give you this kind of stuff. This is more like 3JS and you know, that kind of coolness. But it's also worth kind of looking at what actual websites, you know, like in the wild are doing as well. And just a quick shout out, if you have popped in while I was rambling, I know there's 23 people in here. This is Web Geeks. We're kind of eating up some time until we're ready for everybody to be here, and then we can start into our presentation for the night. But you are in the right place. I'm right now just kind of going through some fun animations, kind of lamenting the loss of Flash, the Flash player that has been completely sunset I believe it's this month. And I don't know if there's any Flash developers out there that you know, want to share any stories or talk about how cool it used to be, or how painful and how horrible it was. You know, jump in if you'd like. This is just not a Flash site, but trying its hardest to mimic those old Flash sites we had. Obviously, Flash was not scalable. It wasn't accessible. Had a whole host of horrible downfalls. But it was fun. It made sites very fun.
I've been playing around with P5 lately. Has anybody heard of that?
No, I'm not familiar with P5.
It was based on, it's called processing. It's like an animation library. So there's a setup block that you use, just a function to set up your canvas, and then a draw block. And it basically like iterates through the draw block over and over again to change everything on the canvas. And there's helpers for like ellipses and rectangles and changing the background of those objects and creating lines and creating motion and gravity. And there's a bunch of models out there for like physics modeling and particle modeling. And even I found a few on like natural selection modeling, because we're thinking about making a game like that. So it's like really accessible and easy to build things animated wise in JavaScript. It's pretty cool.
Very cool. What, P5?
P5, yeah.
I actually have heard of that. Yeah, like a long time ago. Okay, that's been around a little while.
Yeah,
probably
there's
much
a
more mature now.
Oh yeah, it looks like it's got a lot of support. There's a very animated guy, Dan is his name. He has the YouTube channel called The Coding Train, and I've just been kind of having it on in the background, watching his basic tutorials. Because he goes over all the basic JavaScript concepts from ground zero with P5. It's pretty cool.
Cool. Well, all right. It's 6:38, so I think maybe I will launch us into it. Let me switch up my screen though, so that I can see y'all and organize my screens a little bit better and make it less quiet in here. I find it annoying to sit around in absolute silence. So hopefully everybody was able to make it to this event. That's awesome that we're all here. It's fun to see your little thumbnail faces. I'm happy that you were all able to join us. This is a joint effort between DSM Web Geeks and DSMJS. We've been joining forces ever since everybody went virtual and trying our hardest to bring y'all good content the second Monday of every month. If there is ever any content you would like to see, anything you want us to focus on, hit us up, let us know. You know what I'm going to do? I'm going to post some links into chat here. I believe it's these guys, and I'll keep kind of spamming these links throughout the night because as new people pop in, I think they miss old chat content. So there you go. There's a whole host of links. There's Des Moines Web Geeks, DSMJS, our Twitter handles, and our GitHub pages. If you're curious about finding out more information about these user groups, there you go. If you would like to see something, see us talk about something specific, some kind of topic you want us to hit up, shoot us a line, let us know what you think, hit us up on Twitter, let us know. Or if you yourself would like to present, please let us know, and we would love to give you a platform so you can talk. We know that you all are up to some really cool stuff, and you know, maybe you have just a quick thing you want to share or a really long thing. Whatever it is, we can talk about it. Tonight we are using this Zoom client kind of provided to us by Shift Interactive. They are a web development shop in Iowa. If you're interested, shiftdsm.com. You can hit them up and see what kind of cool work they are up to. Or you could go talk to them and see if they are hiring, because they probably need some very talented developers. And if you are here at Web Geeks, then you are a very talented developer. That can be assured. All right, so for tonight, we are going to have Logan Keenan give us an intro to Rust. It should be pretty fun. If you have any questions, throw it in chat, and we'll do our best to answer. Afterwards, after Logan's talk, we'll have a little bit of chance to do some Q&A. After the talk, if you want, you are very welcome to kind of chill out, hang out, and we do this this semi-experimental thing where we split up into groups and kind of talk. And you may be stuck with somebody you don't know, and so it may get weird. But that's all right, and we can all get through it, right? So hang around if you can, because it's kind of fun. If not, then we're happy you all came out, and please hit us up in the future. Let us know if there's anything specific that you ever want to hear us talk about. All right, with that, I'm going to hand off the keys to Logan, and you can get started. You all set?
All right. Cool. Thank you, Justin. Appreciate that. Can you all see my screen?
Yes.
Cool. And I'm going to minimize that. Cool. Well, thank you all for coming, and I appreciate you joining me tonight. My name is Logan Keenan, like Justin said. I'm going to talk about an introduction to the Rust programming language. So we have a lot to talk about tonight. I'm going to cruise through some slides, and through that, I'm going to talk about a brief history of Rust, where it came, also what Rust is, how it's different, some downsides to Rust, and then we're going to start just diving in and writing some code. So ideally, my goal at the end of this is for you to be able to take what you've learned tonight and continue to learn Rust. One of the things that we're going to talk about is this idea of this ownership, and we'll talk more about this in Rust. And this is one of the critical things to understand in Rust. And if you don't understand this ownership idea, it's very difficult. So we're going to make sure that that is understood, and then kind of do extra little language features. So that's kind of the layout for tonight. Let's go ahead and get started. So a brief history. Rust was started by a guy named Graydon Hoare. It was actually a personal project of his back in 2006, and Mozilla ended up adopting his personal project and creating it into the Rust programming language. And at the time, Mozilla was creating Firefox and everything was good, but they wanted to rewrite their components of Firefox, and they eventually wanted to rewrite their browser rendering engine. Now, Mozilla has like top talent. They have great engineers. They're using like the best of tools at the time, but they still struggle to leverage C and C++ and write code that was both safe and fast. So safe being not having memory issues, accessing memories and the problems that are associated with that. And then also along with memory issues come security issues. So they decided to set out to create Rust, which is both safe and fast, and released 1.0 in 2015. Now, between the time that the 1.0 release occurred and when Mozilla adopted Rust, there was a ton of experimentation that went on. Basically, what they did is they took all of the nice things that existed in other languages and adopted those. So as we go through some of these things, you'll notice that some of these features or tools are very similar to stuff that you already use with your favorite web languages. I want to also point out that Rust releases a new version every 6 weeks. So they decided to take the CI/CD approach to language design and use that. And they're also backwards compatible. So if you wrote Rust in 2015, it will work on whatever the next release is coming up. So what is Rust and how is it different? Rust is an all-purpose modern programming language. And I point this out for a reason, mainly because if you went to the Rust website, it would define itself as a systems programming language. And that's still true. It is an enormous improvement if you're writing systems programs. So systems programs being like operating systems, critical software like browsers, embedded systems, so on and so forth. But it can also use it to write any other kind of program that you would with any other modern programming language. So if you wanted to write a desktop application, a CLI, a web server, you can actually write Rust and have it be executed natively in iOS or Android. You can just target those platforms, which is super nice. So Rust is really an all-purpose modern programming language, and it has a lot of the features that you would expect, even though you can use Rust to write systems-level programs. Before we talk more about Rust, I want to talk about this phrase that you see often, and it is zero-cost abstractions. And so what that means is, just to put it simply, is that you don't pay a penalty for having nice stuff, and that nice stuff being like nice features and languages. So an example of this would be using like generics in programming language. Generics can help make your code more concise and readable at times, but you often with some languages pay a performance penalty for that. Now, for web developers, that performance penalty might be negligible, and you just like buy a new server, right, or whatever, right? But for systems level programming, that's a huge leap forward. And so every single extra modern feature that Rust has is a zero cost abstraction. So any really nice thing, you're not going to take a performance hit for. The async await style syntax feature didn't come out until actually last year. That's because it took them a while to make sure that that was actually a zero cost abstraction. So Rust is really defined by two different things. One, that it is fast, and one, that it is safe. Rust is typically, as fast as C or C++. That's about all I'll say on that. Benchmarks are silly sometimes, but Rust is just really fast, and so it makes it great for performance software. And the reason that it is fast, well, there's multiple reasons, but there are two that come to mind typically, is that it has no runtime. So if you think about if I'm writing like some Java app, right, I'm going to compile my code, and then I pass it to the JRE executes my code, and the JRE does all sorts of things for me, right? Rust doesn't have that. It compiles down to machine code, and once you execute that executable, it just runs. It doesn't need anything else. So what that means is that it starts immediately, which is super nice, and then you also don't need the extra size that's associated with the runtime. And so that makes it super nice, again, for systems programming, but as well as web applications. If you're wanting to scale, it's really nice that your applications will start as fast as your cloud provider can provision instances, or if you have any like mission critical kind of software in the web. One other thing that is very unique about Rust that makes it fast is there is no garbage collector. And it achieves having no garbage collector by this ownership idea. And we'll talk in depth about that later. But what that means is when you have a garbage collector in some of your other languages, garbage collectors are great, by the way. You don't have to think about managing memory. They're awesome. What it also means is that you have your app that's running, and then you have your garbage collector that's running, and they're competing for resources on that same app, that same machine. So if your garbage collector doesn't exist, your application is inherently going to run faster. It also means that since there's no runtime and no garbage collector, that your application is going to run in a predictable way because you don't have these other things that could interfere with the performance of your application. Rust also is safe. And for web developers, we don't have to like think about this too much, right? The languages that typically people use in the web manage memory for you thanks to the garbage collector, and everything is great. But if you've come from like a systems programming background, this is awesome. You can write Rust code that is guaranteed to be memory safe. So you will never access something in memory that doesn't exist. You'll never have a seg fault. It's also, you can write Rust code that is guaranteed to be thread safe. So you'll never have a data race. You'll never have threads accessing things in memory that they shouldn't be. And this is all enforced by the compiler. So the compiler does an enormous amount of work up front to make sure that your code is correct and safe. And as web developers, I would say, this is like a nice thing. It makes the fact that it's safe is great. Your program isn't going to have some sort of issue in the middle of the night. But one thing I did notice was the paradigms that Rust has in place that makes it create safe code also makes you think differently about your things that you have in memory or your variables or things like that. And it helps you expose how that variable is used, and kind of reveals different branches of your code that you wouldn't otherwise be revealed with other languages. So that's kind of like a nice extra thing for you. A couple other things that Rust has is that it's inoperable. So this was set out to be that way from the beginning because Mozilla knew that you weren't going to rewrite the world in Rust. You were going to write small pieces. So you can write components in Rust and have it be called from a variety of languages. What I've seen is a lot of people have just, greenfield projects that will do it in Rust, but they'll have projects that they use in their favorite programming language, and then they need some extra performance. So they write that thing that needs extra performance in Rust and then calls that Rust code or the compiled executable from whatever language they're using, which is super nice and a kind of a good pragmatic way to use Rust. Another thing that I don't have listed on here is that Rust can compile down to WebAssembly. And since it doesn't have a runtime, it means that when it compiles down to WebAssembly and runs in the browser, it's much smaller typically than other languages that compile to WebAssembly. So those are some benefits of Rust. Now let's talk about downsides. I think it's important to be transparent when you're kind of evaluating languages and saying like, what are the pros and cons? Rust is a steep learning curve. So there are some concepts, one being this idea of ownership and how it manages memory, which we'll talk about, that is super important to understand. And that's the one thing that I'm going to talk about, spend a considerable amount of time tonight talking about, because once you understand that, all the other things are kind of easier. You can Google how to do certain things that exist in other languages, what you'd normally do with learning a new language, I guess. So again, there's a steep learning curve. Also, there are long compile times. So this is often a common complaint of Rust. And there are long compile times for two reasons, and probably more, but one is that the compiler does a lot more than any other compiler. It's guaranteeing that your code is both memory safe and thread safe. And that just takes some time, I guess. The other thing is that the actual Rust core team has not dedicated time to improve compile times. So while compile times are long now, they won't be long they might not be long in the future. That being said, I've still worked on other projects where those compile times are significantly longer than any other Rust projects that I've worked on. So I don't know. Those are just some common things that people are saying about downsides to Rust. So that's the end of the slides. Let's actually get started. Let's start using Rust. And we're just going to go out to their webpage where you can install it. And what that has is just a script. So what could go wrong? We'll just copy a script off the internet and dump it into our terminal. Go out to developer and install Rust. And this is going to install a couple different things. It actually comes up with this prompt here for me because I already have it installed. I'm just going to go ahead and install it. And this does three things. And I'll show you each one of these items. Let me change my window a bit. Can you see this UR screen sharing stuff down below?
No.
Okay. Just to make sure. All right, that's better. Okay, so it installs three different things, and we'll go over each one of these. One, it installs this CLI tool called Rust Up. So if I just kind of hit Rust Up, it'll go execute Rust Up. It'll open up the help menu, and if you can think of Rust Up as just your version manager. So this is included within your language. If you ever used NVM or RVM, that's what Rust is. Rust Up is. And you can change to different versions. You can also change your targets. So since Rust compiles down to machine code, you need to be specific about the targets that you compile for. So if I build an application and I want it to run on iOS, I need to specify multiple targets that could be available on iOS, or I need to specify targets for Android or targets for Windows, so on and so forth. And Rust Up makes that easy to maintain. I typically haven't interacted that much with this. You kind of just install your target once and then you forget that you're actually doing it. But it's super nice that Rust has this built in for you. The other thing is Rust C. Let me clear my screen. Rust C is just the Rust compiler. And it has a whole bunch of options. So if you want to call the compiler from the command line, you can. Things about optimization, all sorts of different configuration that you might want for your Rust project. This is something that, again, I don't typically use, but it's there and available for you if you need to use that. The thing that I use is Cargo. So Cargo is your package manager. So if you've ever used NPM, they basically took all the nice things from NPM and put them into Cargo. So Cargo is, your package manager. It allows you to build, clean, create a new package. The one nice thing that I'll point out is Rust actually has built-in documentation creating for you, and it's actually pretty good. it will create if you've commented in your code, it will create documentation for you and have a website and all this good stuff. And usually you don't want to comment in your code because it sometimes gets out of date, especially if you have like examples. But the one unique thing about Rust is that when you build your documentation, it will compile and execute the examples that exist in your documentation. So it guarantees that your documentation's examples are actually going to work with the code that is at that version that you are documenting. So that's kind of nice. Let's see, Cargo, the basic registry that everybody uses is called crates.io. And you can go out there. It's very similar to NPM or Ruby Gems or any other registry that you've used. There's all sorts of other things that you can do with Cargo. For us, what we're going to do is we're just going to create a new package or create a new repo or whatever you want to call it. So I'm going to say Cargo new, and I'll say Rust talk. All right, so I created a new binary application called Rust talk. If you noticed, I did an underscore. That's kind of the convention in Rust as opposed to camel casing or whatever you might be used to. Let's go ahead and go into that and take a look at what's in here. So when I create a new project, it's going to create a git ignore for you and ignore all the other files that you shouldn't commit to source control when using Rust, which is kind of nice. The one file that we want to take a look at first is this cargo.toml file. So this is a file that's going to hold information about your package, as you can see by the name, version, authors. It's also a place where you can add your dependencies or dev dependencies. You can add your compiler configurations here. So that's why I kind of said I don't ever use the Rust C, because Cargo builds it for me, and I can define my compiling settings that I might need to have, or any sort of settings that are specific to a target that I am trying to compile for. So Cargo also has a lock file that corresponds to it. It acts very similar to any other lock file that you've ever used. One thing about dependencies with Rust I will say is that it is a flat dependency tree, sort of like Ruby or Java, or not like Node or NPM, excuse me. So it's one thing to keep in mind. All right, let's see, what else can we list? So let's look at the source directory. So inside the source directory, when you create a new package, it'll have a main or a package that is an application. It'll have a main.rs by convention, and that's your entry point into your application. So if you were, as opposed to if you were building a library, you'd have lib.rs, and that would be your entry point into your application. So let's actually run this and see what happens. So if I hit cargo run, it'll compile my Rust code, it will finish it. And by default, when you do cargo run, it does so in an unoptimized and debug way. I want to point that out because if you go try Rust and you realize that, hey, this isn't all that fast, it's because it's done in debug mode in an unoptimized way. And so, as we can see, it's running the executable here and printing out hello world. If I wanted to do that in release mode, I can go ahead and do the same. So that's it, all you have to do for running your application locally, which is super nice. And then if you want to run your application just by itself, again, this is just a single executable. So I can just dump the a path to my executable and hit enter, and it just executes. That's all you need, which is super nice. So that is how you can run your Rust code. Let's actually get into building some, or messing around with it, I guess. So I'm going to use IntelliJ for this. You can actually use the IntelliJ Community Edition and install the Rust plugin and get all the same features that I'm showing you here. Visual Studio is really good as well. And for all the cool kids that use Emacs or Vim, I've been told there's really good support for that too. I would say that the support for the IDE is pretty great now. When I started, it was just okay. And how I evaluate great support for an IDE is, one, if you can debug, but you can, and then also if you can just let the IDE kind of write code for you, and that way the IDE is worrying about the syntactic details. So it's to that point where you don't have to worry about some of those things, and it has all the nice refactoring tools that you'd expect from IntelliJ or Visual Studio Code. So this is our first Rust application. The entry point into the application is denoted by this main function. And so you can create a new function by fn, the name is main, and in this case it takes no parameters, and then the scope of the function is denoted by curly brackets. So it's pretty similar to what you had seen with other languages. There aren't that many differences, to be honest. If you know a couple different languages, Rust won't seem all that foreign. It's just some of the concepts that are a little bit different. So let's take a look at this. The first line here. So the first line is actually our first opportunity to see something in Rust that is different than in other languages that you're probably used to, unless you write C++. So this is what looks like a function is actually a macro. And I know that it is a macro because it has an exclamation point here. And what is a macro? A macro is just code that generates other code at compile time. And so that can be really useful for a handful of things. In this case, I want to talk about why they're doing this for printing out a line, because all you're doing is like printing out a line. Why do you need to have code that generates code? Rust is a strongly typed language. And so what this is actually doing is it's both a string formatter and printing it out. So what I can do here is I can actually say, and then I'll put these curly brackets. What this is going to allow me to do is add, and IntelliJ is telling me something is wrong, is I can add another parameter to this function, and that parameter's value will be injected into our string. So let's actually see this run. And I'm going to bring up my local server here, and there's a crate called cargo watch that I'm going to use. And what that'll do is just look for changes in this directory and then run some command. In this case, I'll do cargo run, so we don't have to go back to this. Oops. Okay. So cool. So I get hello world and 1. Or I can say hello world and we'll do string from Mars. See what that looks like. Cool. Now, I want to go back to it that Rust is a strongly typed language. So if you think about printing using a string formatter and having all the different kinds of permutations that I might need for the things that I just did, right? So I have, I just used a string, and before that I used an integer. So like the method signature for that formatter it would be exhaustive. It just you wouldn't want to create all those possibilities. So you can use a macro for code that generates code at compile time to create the method signature that you need for Rust. And I could also add more parameters too. I could add as many of these little curly brackets as I want. So this is kind of the, so macros are pretty great. You can use them to generate code. You can also, invoke macros like this with the exclamation point, but you can also use macros in a similar fashion as you would use annotations or decorators in other languages. And so what that allows you to do is you actually get an AST of the code that it is annotating and decorating, and you can do all sorts of craziness with that as well. But we won't go into that. It can be super useful for like boilerplate code though, and is used quite often. So we have our main function. So let's start diving into Rust. And I want to dive headfirst. I want to look at one of the most challenging concepts in Rust, so we can talk about that tonight and understand that tonight. So if you want to, if you're not scared away, by the end of this presentation, you will at least be able to go and write Rust on your own and not stumble upon this concept. And it's the way that Rust deals with memory. And it's this idea of ownership. So we'll do this through actually an example and have the compiler tell us what we can't do, and then kind of work backwards from there and figure out why the compiler is telling me I can't do this thing that seems so simple. So what I'm going to do is I'm going to create a function, and I'm going to create a function called hello. Whoops. And it's going to take a parameter. And in Rust, I define my parameter name first, followed by a semicolon, or a colon, excuse me, and then the type. So I'll say function hello, and then have some curly brackets to denote the body of my function. And inside this, we're just going to do exactly what we had down before with that print line. I'm just going to say hello and put in the word that I had. So super simple. Hopefully nobody's learning anything new here. Super simple, just dump out some text in the command line when I invoke this function. So again, let's go down here and say hello. And I'll say Mars. Been watching all the SpaceX rocket launches. This has been on my mind. So we'll make this actually string from. And before we go any further, I actually want to talk about this : syntax here. So this is the string here is a type, and I am accessing a static method that is on the string type. And I can access that through : and you can access static members of certain types with : you can also traverse the module system with : So whereas in other languages, you might say string.of or string.from or whatever, in Rust, it's going to be : It's a little bit different than probably what you've seen before. All right, so if I compile this, it executes, we're gonna see hello Mars down below. Cool. I'm just gonna go ahead and extract this to a variable here. And I'm just gonna call this Mars variable. Oops. All right. So executes just fine. Awesome. I'm gonna just dupe it. I'm gonna do the exact same thing again, right? I'm gonna have a variable that I defined as a string. I give that variable to my function hello on line 9, and then I do the exact same thing again on line 10. Let it compile, and it fails. If I saw this, and what you might be thinking is that this is obnoxious, and learning Rust, I thought this was so bizarre. Why would this fail? This is so simple. I can do this in so many different languages. Why does it not let me compile? And it's giving me some error messages, which we'll talk about in a little bit. We won't talk about this first one, which is actually pretty helpful, but we'll talk about these in a minute. Oh, and by the way, Rust's error messaging is actually pretty helpful. It was inspired by Elm and all the niceness that Elm has. A lot of times when you get error messages, not in this case, but a lot of times you get error messages, it'll just tell you the right way to write your code, which is super nice. So let's back up. I'm gonna delete this for now, and let's talk about memory. And then we'll get back to this and figure out why this doesn't work. So Rust doesn't have a garbage collector, and you don't have to allocate memory manually yourself. So how does that work? How does Rust clean up after itself? So what Rust has is this idea of ownership, and ownership within scopes. So in between these brackets, or these curly brackets, excuse me, is a scope. And inside this, what I'm going to do is I'm just going to say string : from something, some random text, right? And so what's happening when this function executes, I create this variable. Somewhere in memory, my text of something is being stored, and then I execute this code, and my function is done. So when does something get freed from memory? Well, in Rust, what it does is that since this function scope in between these curly brackets instantiated this variable, it is known as the owner of this variable. It owns this. And when it is done, or it's lifetime or whatever, it's done executing, Rust at compile time actually goes and automatically cleans this up. So as part of your compiled executable, what it does is it frees up this memory for you at the end of the scope. So, and it does that because I have ownership for it, ownership of it. So let's think about this for a minute. And that's how Rust gets away actually without having to do any memory management. It just cleans up after itself. So let's think about this example here. Why did this fail? Let's walk through this, okay? So what happened was I have a variable, Mars variable, that's defined within this scope, okay? It's put into memory somewhere, I don't know, it does its thing. I don't have to worry about where it's going or where it lives. And then on line 9, what happens is when I pass this variable into hello, I'm giving hello ownership of this variable. So hello now owns this variable as the name word. And so what happened is this is going to execute. And since it now owns this variable after I gave it to it on line 9, it cleans it up and it just removes it. So it no longer exists in memory. So the compiler is telling me this value used here after it has been moved. And it was moved here. It was moved into this different scope on line 9, and its value is used after moved, and it is gone for now. It has no idea where this is going to exist, so it's just going to fail. So So what happens is I can do a couple different things to solve this. How do I solve this, right? Because you're going to have this, like, this is like the most simple, trivial problem you could think of when you're programming, right? So I can do a couple different things. There's 3 things that I could actually, well, I could do more than that, but I'm going to show you 2 things that I could do. So one, I could do a dot clone. And what that will do is it actually fixes my problem, and it runs, and I see hello, hello Mars. So what it created was this clone function will create a clone of the thing in memory that was being held in the Mars variable, create basically a copy of that, and put it somewhere else in memory, and then pass ownership of the result of clone into this function. So now this function executes, and it cleans up the things that it owns, and the cloned thing that was sitting in memory is now wiped, it's gone. And then it goes down to the next iteration of this, or next part of our code, excuse me, on line 10. It takes the Mars variable, passes ownership of it into hello, and hello then cleans it up after it's been executed. So Rust is able to kind of, through that way, clean up all of the usage of its memory. Now, I could do this, you know, if I dupe this line again, I still run into the same problem, right? Which is kind of like, I don't know, it's kind of annoying, right? There's got to be a better way to do this. But I could just use clone everywhere. And in fact, if you're going out and you're using Rust, I would encourage you to use clone until you have a, you know, you're really used to some of these concepts in Rust. It doesn't matter, like if you're like building a web application that you use clone all over the place, because we have tons of RAM, we have tons of memory. The things that like you shouldn't clone would be like a database connection pool, right? Don't do that. You're gonna have problems. Or like some other connection that you're maintaining or something that's holding state. Like you're gonna probably run it and have a bad time if you clone that at some point in the future when your program's executing. But there's another way we can do this without clone. What we can do is I can actually change the signature of this function, and I can change it to be a pointer or a reference of type string. So I can easily do that with an and symbol. And basically what this says is that I have this hello function that is going to borrow something of type string, and it is going to use it, and it's then going to give it back to the caller of this function. So it's very similar to like if me myself had a physical object and I let somebody borrow something, I would expect to get it back from them when they're done with it. And same thing with like owning something, right? If I own something and then I give it away to somebody else, they are free to do whatever they want with that thing. They can just do anything with it. And in this case, Rust case is it throws it away once it's done. So by defining prefixing the type with this and symbol, I can say that this function is going to borrow the parameter that is passed in. So I can go ahead and update these types to be correct. Right now it is a string type. And also, this is just IntelliJ showing this. Rust kind of can be implicit about its types if you pass it the right value. So I'll go ahead and put an and here to make this a borrowed type of string, and an and here, and it will actually run. All right, so this is where I want to see, do people have questions on this? I wonder if I can see people's faces. Does this make sense? Does this, is this confusing? I don't know how to go.
Hey, I think it's making sense. The only thing that's tripping me up, did you say let Mars variable colon string is interesting? Okay, so okay, that was something shadowed in there that's not actually typed. I see.
Yeah, so I don't have to define types like on everything. Usually it can be inferred, which is nice. So even though Rust is strongly typed, it'll do a lot of inferring with you. If it can't, it just won't compile, and then you have to put the type in there. So that's kind of nice.
Mm-hmm.
Any other questions on that?
Is there any way early on to say this variable should always be available, or is it only like when you pass it in that you use .clone or the ampersand?
You could certainly make like global variables that would always be available. There are actually two kinds of strings, and there are strings that will always be available, and they are always borrowable. But I won't get too far into that. Strings are actually really complex data types. I didn't realize that until learning Rust. There's actually like some talks on YouTube where somebody talks for like an hour and a half about the differences between the two types of strings and how complex the string data type is. It's just these higher level languages abstract all of that away for us. But I could certainly make something that lives for the lifetime of the application. I could make something that's like static. I could make something that's global. You actually, to make global variables in Rust, you actually have to wrap it in this unsafe syntax, because if you have multiple threads, you need to be able to pass that global variable appropriately between those threads. Just anyway. Does that kind of answer your question a bit?
Yeah. I was curious if it was like an anti-pattern maybe in the language too. Seems like it wants you to go down the path of knowing what's going to happen with it, where it's going to get used.
Yeah, and you don't have to do this all that often, to be honest. Like you might have to think like, oh, I have to use this like and string thing to pass variables around and they're going to get cleaned up. You don't have to have that. I'm going to show you, we'll talk about traits and structs next, but I'm going to show you something in this compile error where it said it didn't have, well, actually, I'll just show you in this example here. This is only for certain types that you have to kind of borrow this way, for like special types and special structures. For things like integers, you don't have to do that. So if I created a function called double and I had some num, and that's of type I32, I could then return num times 2. And then to do a return syntax, it's just this little hyphen with the greater than arrow less than symbol. And if I were to call this, so let's again make a variable, and I'll say let num to, I cannot control my caps locks. There we go. 5, whatever. I can do this, and this isn't a problem. The reason is that this type, so which is also probably a little interesting, is that the signed integer of signed 32-bit integer, this I32, actually has a trait on it that allows it to copy itself. And so it can create a copy of it, and Rust just knows, oh, this type is able to copy itself, and I'm just going to do that instead of borrowing it. So sometimes you have to use it, sometimes you don't. So while it might seem like you have to do this all the time, it's only for really complex data types. Like numbers are pretty simple, right? To an extent. But strings, structures, which we'll talk about next, those are a little complex.
So are traits an actual language thing, or is that a term you just use right now to describe it?
Traits are a language thing, and I will talk about that.
Ooh, fun.
Any other questions? Feel free to we can go back to the beginning too. This is like a not so easy topic, I think. Once you have a good grasp of it, it makes you fight the compiler less, which is nice.
Hey, and just in case it helps anybody, in chat, I threw a link to a shared code editor. So anybody can hop in there and share your code. And I threw a link to the playrustlang.org, which allows you to actually run the code that we are watching Logan type.
Yeah, that's a great resource to try stuff out if you don't want to have to install Rust and install an IDE and all sorts of things.
Logan, when your function signature specifies that it's passed by reference, the arguments, do you have to pass it by reference like you do on line 13, or is it like, a C++ where you don't actually have to pass it by reference like that?
You have to pass it by reference. And Rust will say that these are not compatible types. So by saying it's a by reference string type, it can pass it there. It can pass it. You have to do that. Yeah, I'll be interested, Trevor, in your feedback after this, since you've done a lot of systems programming. So, cool. Any other questions? Great questions, by the way.
Hey, Logan. I have a question regarding the data types that are allowed by Rust. Can you just go over all the data types that are supported that can be passed in?
Yeah. I'm going to Google that. So there's a lot of them, and like all the things that you would kind of expect with Rust that you'd have. There's a whole bunch of types of integers that you might need. So there's a difference between a signed and an unsigned integer. So, and I'll just explain that briefly. A signed integer, which is denoted by this I here, is anything from, like, in this case, a signed 32-bit integer is anything that is like the negative 32-bit integer max to positive 32-bit integer max. Whereas an unsigned one is just all the positive numbers that exist in a 32-bit integer. So it kind of goes back to some of that systems level programming. Like if you know you're going to have, if you are resource constrained and you know you're only going to have a positive number, then you're going to use an unsigned integer. So I always just use signed integers because I don't need to have any optimization. Let's see. So, I mean, there's arrays, there's what's called a vector, which would be a list. There's basically all the kind of types that you would expect in any other language. There's tuples. We'll talk about structs, which are like classes. Yeah, there isn't, trying to think. Yeah, there's everything that you would expect. I haven't ran into something and like, oh man, I wish I had that type because I have it in this other language. It exists in Rust, more than likely.
Okay, thank you.
Yeah, great question. Anything else?
Is Rust similar to JavaScript where you can, convert, strings? If you have a JSON object, you can convert it to string. Does it have its own way of doing that, or like, is there a JavaScript? You have to use JavaScript to convert.
So are you talking about passing? Well, so if you need to like parse a string value into an integer or something to that respect, yeah, Rust has that built in and you can do that. And you'll have to handle if it doesn't actually work because you tried to parse ABC into an integer or something like that. Mm-hmm.
I was thinking more like a conversion function, where if you had JSON, you were calling it from an API and you wanted to convert it to a string. Would you have to use a JavaScript function to do it, or does Rust have an inbuilt function?
No, Rust is all by itself. Rust has a built-in function for doing that. There's a great library called Serde, S-E-R-D-E, that handles an enormous amount of type coercion for JavaScript JSON objects. So if you're calling an API, casting the things that come back to the correct data types or structures and things like that. Yeah, great question.
Use like a throw catch too with Rust?
No, there are not exceptions in Rust. They do not exist. Huh. Great question. So you kind of have to handle all your code paths, or just choose not to if you don't want to, if that like path in your code doesn't exist. Yeah, there are not, the idea of exception does not exist. Cool. All right. So the one other thing I want to talk about is structs and traits, because those are some different. We have ownership, this concept. This is very different than other programming languages. Structs and traits are a little different as well. So usually in some of the languages that we've worked with, we've had classes and inheritance. So this structs and traits are going to kind of play that role to a bit. And I'll show you how that works. I'm just going to comment this out just for kicks. And this will also kind of show off Rust's module system and how that works. That's a little bit different, only slightly. So I'm going to go ahead and organize this just arbitrarily. And I'm going to make a package called models, or a folder package because it's a Java editor, right? So in order to actually use the things inside of this folder, I have to actually specify this as a module. And I'll show you what I mean. I have to like create this file called mod.rs. That naming convention is specific. And so from here, now I can kind of build out my tree structure that is the modules within my package or my project. So you'll notice here that actually IntelliJ is helping me. It's saying this file is not included in the module tree, so analysis is not available. It also means that this module or this Rust code is not going to be compiled. So what I need to do is I actually need to go back into my main function, and I need to specify that this main function is going to leverage the modules that exist in modules. And so now if I go back into mod.rs, it's available. So, you know, Rust compiles like to this executable, right? The idea of a directory structure doesn't exist once you compile to machine code. So you have to build out your module tree yourself, which is a little bit different and I would say cumbersome. At first, if you're using an IDE, it's really easy because IDE fixes all of your errors for you. So I'm gonna go ahead and in this module, I'm gonna create another module that is going to be our example for demonstrating structs and traits. And I'm just going to use the like classical like computer science inheritance thing that we've probably all done, where you have like a dog that inherits from animal, and you have some shared functionality between them. And you also have like a cat which inherits from animal. So we'll kind of go over this and how that works with structs and traits. So I'm going to go ahead and say public mod dog and let IntelliJ do some of the heavy lifting. It'll create a file for me called dog.rs. And inside this, I'm going to finally define my struct. And I can organize this any way. I just kind of wanted to show you how this module system works, because it's a little different and it's confusing when you first start using it, I think. So I can define a struct. And a struct is just a data structure that holds some data, right? It doesn't have functionality when you define the struct like a class does. You only define the properties of it. So in this case, I'm going to give my dog a name, and it's going to be of type string. So I could create, you know, all sorts of other things. I could say I32 for age. I could say it has a trick, and I could actually pass it a function, lowercase function. So I could store the function inside my struct if I wanted to, and kind of do some functional programming with Rust if I wanted to. But the big takeaway here is that the struct is just a place to store data. So how do we actually, so when I define my struct, it's just a place to store data. So how do we actually like add some functionality to this? So what I'm going to do is I'm going to just say dog, and you do this through the impl keyword. So I can say impl dog, and what I want my dog to do is I want my dog to bark. So within this scope here, I can define different functionality that relates to my struct dog. So I'm going to define a function called bark. And in this, what I want to do is I want to print a line, and I want to say the name of the dog says ruff ruff, whatever, right? And what I want to do is I want to actually put their name here. So what I'm going to do is I'm going to pass it the instance of itself. And again, I have to pass this as a reference, because if I just didn't, it would pass the instance of the dog that I create somewhere else in my code. It would invoke this code and clean it up and remove it from memory. And that's probably not what we want. So I'm going to say self. So now I can say, put my little curly brackets and pass in self.name and reference that right here. Okay. So let's go actually implement this and see what it looks like in my main function. All right. So now if I just want to create a new dog, I just have to say capital dog with curly brackets. And I was hoping, I actually have to make it public too. So public being just pub if I want to. And I knew I needed to make it public because IntelliJ is going to do some heavy lifting for me, and it's actually going to put the import syntax for me up at the top. And so what I need to do also is IntelliJ is telling me, hey, I have missing fields here. Because when I defined my struct, I said that it was going to have a name, and I didn't declare that as optional. where I could declare that as optional and it wouldn't be required. I would still have to define it here, but I could put, I wouldn't have to put a value in there. So I'm just gonna call this Grover, I don't know. And now I've created an instance of a dog. I'll extract this to a variable for me, and I can say dog dot bark. And it's saying that it doesn't have that, so let's still check with that. And that's because I didn't make bark a public function. Okay, so now I have, let's go back. You can see that down here it says Grover says rough rough. Awesome. I have a data structure for storing data, and then I can add functionality on top of that data structure. You can just keep adding to that data structure, and I can do multiple impulls if I wanted to. I could add that at different points, areas of my code if I wanted to organize that. Typically, I just add it here, and then if you have another area of your code where you need to add functionality, maybe that lives in that area too, because that's where it makes sense. It's kind of a nice feature of being able to add functionality to that struct. So what if I want to make, so now I could do this to make a cat. I'm going to do that. I'm just going to copy and paste this because it's very similar. And I'm going to make a cat that says meow, and it has a very similar thing. We'll attach to the mod RS, letting, again, IntelliJ do a lot of heavy lifting for me. And I'll change this to actually a, whoops. I'll change this to a type of dog, or a type of cat, excuse me. And the cat says meow. And we'll say it says meow. Okay. So now, what if I wanted to have, this is where kind of traits come in. So now what if I have all of these types of animals, right? Well, what if back in my main function, I'll go ahead and make my cat again, just for kicks, really quick. What if back in my main function, in my main application or some other function, I wanted to be able to take any of the animal types that I have and pass them to some arbitrary function and have that function see what noise that specific animal makes. I'm gonna go ahead and fill this out really quick and call this Garfield. I don't even know if that's how you spell it. All right, we'll extract this to a variable as well. Okay, so what I mean by that is, I'm gonna delete this because it's distracting, is, you know, what if I had a function here that was called animal noise? And I wanted to be able to pass in a cat or a dog and see what noise it makes. You know, and in order to achieve that, like I would have to have some way, some sort of type to be specified as a parameter that has both the characteristics of a cat and a dog. What I can do is I can actually achieve that by creating a trait. And so I'm going to go ahead and I'll just do this here because I think that'll be a little easier. I can just define this by a trait and call this animal. Okay, so you can think of a trait as like an interface. A trait is going to define specific behavior that you want out of this type. And in this case, the type is animal. All right. So I'll go ahead and create a function on here that's called noise because I want to figure out what's the noise this animal makes. And it's going to pass it an instance of itself as a reference. And now I can define my parameter here. So I'm going to go ahead and say animal. And it is a parameter called animal, and it is of type animal, and it is a borrowed reference. And so when I just, now I can say animal, noise, and it should do whatever noise the animal has. Let's give this a shot and see what happens. So I've defined my trait, which is my functionality that I expect for my other structs to have. And now I'm going to pass my dog into that. We should get an error message, I imagine, because it's not the same type, right? I'm going to pass it as a borrowed type and hit save. So it's saying that the trait animal is not implemented for dog. So if we go back and we think about our, you know, the impl keyword that we used before, we can also leverage that same syntax to implement dog for animal. So if I go back into dog, what I can do is I can say impl animal for dog. And now I'll let IntelliJ build out this code for me. Now I can implement the behavior of an animal for a dog. So in this case, all I have to say is self.bark. And so what will happen is now if I save this, we'll see that my code executed and Grover says rough, 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 right? And that's all just done through by passing that type that is both dog. That is, dog also is now considered both a dog type, and it implements the animal type. So it is able to execute and compile correctly for that. So traits are kind of like this, like kind of a way in which you can use inheritance, but not quite. You're really just taking things, or, you know, I don't want to use the word trait, but functionality, and applying that to different objects. And if you think about how, like in evolution terms, that's kind of more like it, right? I don't say I inherited all the things from my mom and all the things from my dad. I inherited traits from them. And then I can just use, and then I get to express those traits and use those traits as I live, I guess. So traits are kind of different. They are something to get used to, but they also can be really powerful. There are times when I think, oh man, inheritance would be really nice here. Are there any, what questions you have on that? I kind of went through that quickly because I know we have coming up a little past the hour here. Questions on that, or things that were confusing, or things that I can walk through again?
Logan, that doesn't support duck typing, does it? Like if you had made dog and cat noise rather than bark and meow, that would still be a compiler error, right?
So if
like you have to actually implement that animal trait.
Oh, so if I already had something that was noise and it had the same signature?
Yes.
Oh, I don't know. I'll try it. I don't think so. I think it'll be a compiler error. Yeah, it says it's not implemented because I have to implement it because I'm passing it in. Yeah, method not found in dog. Yeah, it's just going to give me issues. It does not have duck typing.
There's a lot of stuff reminding me here of Scala, so it just made me wonder if that would work.
Oh, okay. I do not know Scala, so that's interesting. I'll have to read up on that a bit then. Yeah, great question.
Can you implement traits for types defined in external modules?
I don't know. Well, I can't remember if you can't implement traits or you just can't add more implementations to a module that's, or types that are defined in other modules.
Okay.
I'm sorry, I don't have that answer. One of them you cannot do because I tried to do that to try and, I think you can add traits, but you can't add members, or you can't do like this, impl dog. So
Okay.
I couldn't have some other struct that lives something else, somewhere else, and like extend it a little more, but I can apply it. Yes, that's correct. Okay, but I can apply a new trait to that. So that's my opportunity trying to extend the functionality of that struct.
Okay. Yeah, so kind of similar to the Scala anecdote, I'm coming from C# world, and that's kind of like an extension method thing I'm used to.
Okay. Yeah, cool. Yeah, like I said, like Rust just took a lot of things that worked well in other languages. And it's like, why reinvent the wheel? Any other questions or comments about that? Cool.
I'm also wondering if you go back to the dog specification, or whatever you want to call it, module.
Yep.
You said that you could specify a function as an attribute of a struct.
Yes.
What would be the main difference between that and specifying like an implementation of bark as opposed to like an attribute of the struct as bark?
I don't know if you will have access to self in the function that you pass in as a property. So let's say I have, I don't know, trick, right? And it's an FN, And it is you won't have access to the self in this function. So because when I go back to this and it says I need to add my missing fields, like I can't go ahead and pass the instance that hasn't been created yet into the constructor of itself. You know what I mean? So I pass some like generic function into this and it would be fine. Does that help answer your question? This is how you could create a generic function if you want.
Yeah, for sure.
So
this is awesome.
Yep.
So you can't pass self, but in that struct definition, can you define the signature for the rest of the function?
Yeah, so you could find the signature as it's, I believe you could find this, so you could define the signature of this function using the type that is dog. So it would be like a weird way to implement it. But you could do all sorts of, gymnastics with that, which I've done. If that makes sense. So I could say something, or like say self dog, and it's a type dog. That's not going to be quite right. I haven't had to do generic functions all that often, but you could pass whatever kind of type you want into this. It would just, the way you call it would be a little weird. Yeah, great questions. Anything else? Anything about, this is kind of as far as we'll get tonight on this talk. These are some of the concepts that I thought were, the most foreign compared to other languages, at least the ones that I've learned. I guess some other languages have these as well. But I wanted to make sure that one, ownership was understood. And so that way, as you're going and you want to pursue and learn more Rust, that you have a clear understanding of what ownership means and how to borrow variables and so on and so forth, along with structs and traits, because they are different than what you might be used to with classes and inheritance. Otherwise, a lot of things are very similar that you'd see in other languages. And, usually I've had success with just Googling like what a list looks like in Rust. It's actually referred to as a vector, or any other sort of arbitrary thing you'd have while learning a language. I do have on my slides, I do have resources that are available and that I found useful. There is actually a free book, the Rust programming book. You can buy this on Amazon if you want, or you can read the digital copy. I've linked a few different YouTubers here. I believe this guy is now going to work at Amazon, but he has a whole bunch of in-depth topics. He recreated a database in Rust for his PhD thesis. Ryan Levick works for Microsoft. He's rewriting a lot of core pieces at Microsoft to take advantage of the memory safety that exists in Rust. There's also a Rust by example website that helps. There's a website called Are We Web Yet? That has been updated over time, and it kind of talks about the state of Rust libraries and Rust in general for doing web development. And then it lists a whole bunch of recommendations. There's also This Week in Rust, which is a mailing list. And then, of course, I linked an awesome list for really cool projects that exist in Rust. So I really appreciate everybody coming to my presentation and taking the time to learn some Rust. And feel free to ask me any questions you have about Rust. And I appreciate all the questions that have already been asked. Was there anything that you wanted to ask that wasn't relevant to what we were talking about at the time? This is kind of your time to ask those questions if you'd like.
Looks like somebody posted in chat about essential tools and popular packages.
Let's see. Essential Rust tools and popular packages. So the tools, I've gotten away with being able to, I'm reading some of the other comments. Those are great. I've gotten away with just using Cargo. That Cargo Watch tool that I had was pretty good. For the most part, I haven't had to use too many other things. They did a really good job of just learning from what other languages are using. Popular packages, I would look at Are We Web Yet? And they're going to have all sorts of great recommendations coming down to an ORM. The person that created Diesel actually did a whole bunch of work on Active Record and then went over to Rustland. There's native drivers for all sorts of things, all sorts of other databases, WebAssembly, and then you can kind of go to drill down into here so you can see all sorts of other libraries that exist for the things that you need for web development. Actix Web is the web framework that I've used most heavily. Cool.
Anybody else? Jump in if you if you'd like.
Hey, Logan, could you talk a little bit about testing and maybe how that compares to maybe JavaScript or other languages?
Yeah, I wish I could. I haven't actually gotten into testing. I have just been writing a lot of Rust code and just kind of making small modules, and that's helped out. It's surprising how, if you can get your code to compile in Rust, it's like it's going to work. It's kind of odd, or it's very obvious on the places that aren't going to work because of the way you don't have exceptions. So you have to handle paths and things that could go wrong. With that being said, a lot of other people do testing. I think testing is actually built into the language itself, and then there's a whole bunch of other frameworks here that you could look at. So sorry, I don't have a great answer for you on that one. I could do a talk on that though. That'd be a good way to learn it.
Right. Awesome. Okay. So thank you very much, Logan. That's great. Maybe we can all just kind of like virtual clap silently and awkwardly for you. There it is right there. Hopefully you can, maybe you're in gallery view and you can see that. If anybody's curious about catching this talk again, so I did something kind of experimental, and I put the this on Twitch, oddly. So it's you can rewatch it there. Logan, could you shoot me back hosting privileges, please? All right, now I am going to transition into the next phase, which if anybody is interested in, we are going to do this fairly, I don't know, awkwardly experimental deal where we split out into breakout session rooms and chat with some random people. And it straight up lasts for like 3 minutes. I set a timer. You guys know when it's ending. I'll warn you when you're gonna break out into rooms, groups of 3. You can stick around if you want, or you can pop off. Don't worry about it. It's totally cool. This is just one way that we can help keep our community together and get to socialize a tiny bit. Topic at hand is the best thing to talk about, and but if you're looking for any more icebreaker ideas, certainly figuring out somebody's name is a good one. Where they're from is also really clever, and lots of conversations can start out from where you're from. Okay, so in a few seconds, you're all gonna pair off into 3s. So get ready. It just goes and it goes and it goes, and then maybe it has stopped, possibly. Hello, how's it going? Hi. Is it yeah, I think you're both muted. I'm gonna work on setting a timer. I don't know if you can hear me, Shane, but you're muted. I haven't been keeping track of the time very well, but I'm fairly certain everybody has been there for at least 2 minutes. So let's close all the rooms, and then that should draw everybody back in a minute. Okay, you're all popping back in now. All right, hopefully that was not too painful for y'all. I think that's cool. Hopefully that's fun for everybody. Hopefully y'all had a good time. I won't force you all to do it again though. That's we ran kind of long with our talk, and it's getting pretty late, and so I think now would be a good time to wrap it up. I'd like to really thank everybody for coming out and attending this event. Thank you so much, Logan. It was a really awesome talk. I hope everybody can check out Rust. If you are interested in future events from DSM Web Geeks or DSMJS, hit us up at our respective websites. I threw those links in the chat, or it's dsmwebgeeks.com and dsmjs.com. Again, if you want to see a recap of tonight's talk, I awkwardly recorded the whole thing on twitch/dsmwebgeeks.com. Like I said, this is a new thing. I haven't really done this before, but it is like the easiest way that I can get video out onto a service without having to edit stuff and that sort of thing. So hopefully it's cool. Hopefully it works out. Maybe I'll continue to do it in the future. With that being said, let us know if you guys want to see any topics in the future. Look forward to what we do in January. No word yet, but we'll come up with updates soon. All right. Thanks, y'all. Have a good night.
Thank you, Justin.
Mm-hmm.